smaller than 30 sample size, you're going to have to go get more data. Well, or just give up the phone. But if you want to create a confidence interval, you really do need get more data. So, if I put on the test, you have 20 observations, create a confidence interval for the population mean, but I don't say anything. Then, for the test, the correct answer is you do not have enough information. Right? You have to know the distribution of the population itself. If, however, you do know the population distribution, at least roughly, then you again get two situations. If you know sigma, it's a non-issue. Because if you know x is distributed normally, and you know the population standard deviation, it doesn't matter if your sample is 1, 2, or n. In all cases, x bar will be normally distributed. So you just use the large sample first. On the other hand, if you know the parent population is normally distributed, but you do not know, then you have to estimate. And the problem there is, while you could ignore the effect or the uncertainty of the random variable s when n was greater than or equal to 30, when you have few observations, well, now you have two sources of uncertainty, the random variable x bar and the random variable s. Yes? So the question is, what is more difficult to nail down? What has less precision? Just having an x bar divided by a constant, or x bar divided by another random variable? That has less precision?
No.
More precision, okay. Good, yes. And in fact, what ends up happening is that instead of a normal distribution, you just get something with slightly fatter tails. And that something is called a t-distribution. And it looks very similar to the normal. This is the normal. Except, like I said, it has fatter tails. So, and what's true, so these are t-distributions. These depend on your sample size, where n1 is less than n2, is less than n3, is less than infinity. And what's happening is that as your sample size gets larger and larger, you are squeezing the t-distribution down until it conforms to the normal. So as your sample size gets larger and larger, you're removing the uncertainty from S and driving this down into the exact same shape as the distribution for x bar. T is symmetrical. It's centered around 0, has the exact same mean, median, and mode. The choice of which t-distribution depends on S through the degrees of freedom for S, which, remember, was n minus 1. Okay, and if you have that situation, you simply substitute t where z used to be, and you're done. You have a new confidence interval for a small sample estimate for mu. So the only real question is, well, how do you look up the distribution? Let's just use an example here. We have 10 units in the sample with a sample mean of 550, a standard deviation of 60, and we're going to create a 95% confidence interval. Well, if you have a large sample, a 95% confidence interval should immediately tell you 1.96, right? It's easy for 1.96. But now we have to use a t, which we know has a fatter tail. So instead of 1.96, in order to capture 95% in the sort of middle part, you're going to have to be further out. question is how much return? Well, you look at the upper tail, which for 95% means you have 0.2025, right? 2.5% in the upper tail. You also have 2.5% in the lower tail. If you look at the upper tail, and then you take the sample size minus 1 to get the degrees of freedom, and at the intersection you get 2.262, which is slightly more than 1.96. Any questions on how to read the T-table? We just look at it in the book, or is that all right?
Where in the book is it?
9th edition or 10th edition?
9th.
Inside front cover. Well,
there it is.
actually, it's right next to the inside front cover. 900 and something.
920.
920? This is why I don't like this particular innovation. I don't think it was tremendously wise. Okay, so just to confirm, you look up 0.25 right there. I guess it's almost unreadable, but 9 degrees of freedom is right there. Follow that across, and you get 2 point. I don't know if that's readable here. Yeah. 2.262. Yes. Okay. So you put the two pieces together. P and standard deviation and square root of n and x bar, and you find that the confidence interval is 550 plus or minus margin of error of 42.96, sorry, 92, which gives you the final answer, which you conclude as we are 95% confident that the true mean population mean of rents of one-bedroom apartments within a half-mile campus lies between $507.08 and $592.92. So, what's my next question? Okay, very good. What is the probability that the true population mean for rents of one-bedroom apartments within a half-mile campus falls within that interval? 0 or 1. Excellent. Does that make sense to everyone? It's important if you're definitely going to get the question, how do you interpret it? And I'm almost certain that in real life, if you ever run into any statistic, you will run into a confidence interval. What proportion of one-bedroom apartments will have rents within those two numbers? Excellent. Now, in one of the previous classes pointed out correctly that we can come up with perhaps a little bit of information, because what we need is a distribution for x. But we've made the assumption that x is distributed how? Normally. Right. So what you can do is you can come up with some bounds for what proportion of rents must lie within that interval. We're not going to go there. That's for the special needs. Okay.
So I got Scott, one quick question.
Yeah.
So this is all under the assumption that X is distributed normally.
Right.
Is there a way that, like, if you have data to test whether it actually is or not?
Oh, yeah.
So
For you, for just practical purposes, create a histogram, or stem and leaf, whatever you want, and just make sure it's roughly mound-shaped this measurement. That's sufficient. And literally, for most cases, that's enough. What you do, if you want to do this formally, is you set up a hypothesis test, and you come up with an estimate for how many observations should be within certain intervals. And you can do this very formally. But the problem is that unless you set up a system that is very, very strict, basically your null hypothesis is, well, I know I'm using terms that we haven't introduced yet, but your assumption is going to be that the distribution is normal. And you can always create your test so that you are unable to conclude that your distribution is not normal. It's exactly like a court of law. Your nullus hypothesis, your assumption is that the defendant is innocent, right? It's the American way. You can always set up a trial so that it's basically impossible to convict the defendant. Yes? So it's the same idea. You can just simply make the assumption that you have a normally distributed trend population, and then you make it impossible for you to reject that idea. You haven't really done much. So in reality, if you just create a histogram and it's more or less round-shaped and symmetrical, then you're good to go. Well, if it's clearly skewed like this, or just two different outcomes, then you got some explaining to do.
Some what?
Explaining. Lucy? Was that my love, Lucy?
Mm-hmm.
Before your time. I think it was my mother's favorite show when she immigrated to this country. So, yeah.
I'm gonna say, I'm pretty sure that was before your time as well.
Yeah, it was
Well, no, actually, I'm 102. But I just like that word, explaining.
It's good.
That's explaining too. And
But for project purposes, we just assume that it's going to be distributed.
for project purposes, create a histogram and comment sagely. Other questions that I could help you with by not being helpful? Yeah.
Is there any tools which of any tools we can just put in data and then it just
Here's what.
chart against that?
Actually, I think if you go to Excel and just use data analysis, it has a histogram tool.
Okay.
It also has a descriptive statistics tool, which gives you a whole bunch of stuff. Including mean, standard deviation. I think it gives you most of what you need for box plot.
Okay.
The stem and leaf would be separate.
Yes, absolutely. Okay. So the only other question is, how do we interpret how do we do this in practice? So let's look at an example before we get to sample sizes. So we've got a number of households, and we literally number them from 1 to 20. So n is 20. These have ads, which we label X. And total male, we'll label that Y. And there's a claim that the proportion of ads that is, I'm sorry, proportion of total mail that are actually advertisements is approximately 70%. Okay, come up with a point estimate of the population mean number of advertisements received per week. So by point estimate, what are we looking for? Are we looking for the rifle or the shotgun?
Rifle.
And so, what is our rifle bullet? It's the probability the rifle bullet will hit perfectly, yes, but what is our estimate here? What number? How do we find the number? What represents the number? Mu is where we're trying to estimate. What are we using to estimate mu? If we're trying trying to estimate the population mean,
Next bar.
there you go. And so we just add up all the adds, divide by 20, and we find a mean of 16.8 and a standard deviation of 4.25. So in a situation like that, you have to have the assumption that X is normally distributed before you can proceed. And you also have to have the assumption that Y is normally distributed when we get to that. So that's the point estimate for the population mean of advertisements received per week per household. We're also asked to come up with a 95% confidence interval. So a good first start is always to write down what you're looking for. It's going to be X bar plus or minus some T times so what do we need in order to find T?
And
Very good. So N is 20, and that gives us degrees of freedom equal to 19. And if you have 19 degrees of freedom and a 95% confidence level, can you find the requisite T? What is it?
2.093.
How much?
2.093.
Any questions on how to find that? How to read the table? Okay. So we plug that in. We get 16.8 plus or minus 2.093, 4.25, square root of 20, 2. $14.81, 18.79. Okay, anybody care to do the honors? How do we interpret this? How do we conclude?
$16.8 is in between 14 and 18.
Yes.
That will be
But remember, 16.8
We
was our
are
simple mean.
95% confidence in the rule.
We are 95% confident that the mean is between 14.81 and 18.79.
You left out a key word though. Interval.
Population.
Population. We're 95% confident that the population mean number of ads received per household per week lies between 14.81 and 18.79%. And what is the next question? Of
Mean, population mean, being in that interval.
and the answer is
0,
0 or 1. Very good. Almost getting to the boredom phase, which I like. Yes. Once you have the proper level of boredom, then we can stop asking the same questions.
What is this telling us? Yes, I get the 95% confidence, but we've already identified what the population mean is. So
Have we?
16.8.
No, it's just a sample. That's the sample.
Sample mean. Okay.
Right. We're interested in the mean number of advertisements for the entire country. We have 20 households. So the probability that the mean for the entire country is 16.8 is 0.
Our sample mean is 16.8.
Exactly.
Our population mean is in there
Maybe.
with 95% confidence.
We're 95% confident, and there's a 0 or 1 probability. And the last question.
One question on this. So if you give that kind of statements to general public who doesn't know statistics,
Which statement?
like that, okay, they have 95% of chances of having the mean, population mean in between this interval. We are confident, 95% confident. Our mean is going to be in between this population.
I'm just asking, that's the statement you want to make, okay, and so what's your question about general
So,
public?
I mean, what kind of inference we are going to make? I mean, just out of, you have this 20 out of US population, I mean, this sample it's not going to tell anything. And
Actually, if you do this properly, an interval of this width, which is only 4, right, will hit, the population mean is going to be inside this type of interval 19 times out of 20. Yeah.
For 95% confidence, it will be.
Oh, it will.
If it doesn't, then Ray has wasted his life, so.
No, I confused the generation. That's my life's work.
All he wants to do is be a member of the club, remember?
If you're asking how to present this to people who've never had statistics, I would argue there are 2 ways you can do it. You can basically say, we are 95% confident that the true mean lies between 14.81 and 18.79, and let them use English to interpret what you just said. Or you can go through and explain what we've just spent quite some time talking about. The reason I think that's necessary is that, people have a pretty good idea of what's meant by confidence interval in the sense that they know, it's a little bit better than just coming up with a single number. But on the other hand, they really, unless you define the terms clearly, they're not going to come up with the idea of a confidence interval on their own, at least not immediately. Dave?
The statement, we are 95% confident that, and there's a 95% chance that, are those equivalent?
Not in my world.
Okay.
I use the word chance to be a synonym for probability, and probability is something quite specific.
Okay.
You have to have an uncertain outcome in order for there to be probability. You have to have an experiment that can take on different values, actually have different values with different rates, but you can assign numbers to the rates at which they happen. Other questions? But, well, before I forget, an uncertainty itself has an also very clear definition. It is when you use the word uncertainty when you know that there's no way to say exactly what's going to happen in a situation, but you cannot assign probabilities. And that's, even harder to work with. Okay. Did we all address your question? Okay. Excellent. So, to finish the job, we're asked to come up with a similar animal for the total male mean. And what changes? Take a look at this and tell me what changes when we're going to come up with a confidence interval for all of the male. And while you're telling me that, I'm going to just write down the mean. Okay, so in the confidence interval, what changes?
X bar.
X bar changes, good. We're going to use Y bar. What else? S. And that's it, right? Sample size and T don't move around. So the new confidence interval is going to be Y bar plus or minus T S square root of N. So we've got 24.1 plus or minus 2.093. Oops. My point got a little waylaid there. Or mislaid, I guess is the word for it. 6.21 square root of 20. Okay. should pretty much be able to step aside and allow the conclusions just to pour forth. An uncontrollable flood of joy and statistics. Yes, I live in a fantasy world. Anybody? I feel like I'm neglecting this side of the room. Maybe I'll come and just stand here.
You serious?
No, just picking on you.
Dave would say.
We're 95%
I
confident
can't.
that the interval contains a population of 21.2. I messed that up.
You kind of put the pieces around a little bit, but you're pretty much on the right track. Just try that one more time.
We are 95% confident
That.
that, that 21 point, that the population contain,
That the population even contains?
no. Is within the interval 21 to 27.
Okay. And does the population mean, just to put it in context of the problem,
Of the total.
total man per household, very good. And the probability that that population lies within the population? Excellent. And the proportion of households that get that quantity of men? All right.
I would have said something, but I was too bored.
Well, then you are a master. So you're done. Are there any questions on the interpretation for means? This is the last one we're going to see today. Yes.
You asking about the proportion and us saying we don't know. At some point, will we know? Are we getting there?
No,
Okay.
because that's something that you can estimate if you have more information. And if I gave you more information, then we'd be back into territory we covered 2 weeks ago or 3 weeks ago. What's that?
Plus second shot.
Right, exactly. So we're done basically with that material. But if this was important to you on the job, I'm quite confident that you'll be able to get there pretty easily.
How confident?
95%.
What's the probability?
Well played.
Okay. Last part of the question. We're asked to comment. We're asked to use the 24.1 and the 16.8 to say something about whether or not we believe that 70% of male is, advertising. How can we use those two numbers to tell us anything about that ratio? Kind of look cat out of the bag there, isn't it?
Calculate the ratio.
Excellent idea. All right, so we take 16.8 and divide by 24.1. We get 0.697. And what does that tell us? Or how do you feel about that number? It's pretty close to 0.7, right? But the interesting question, which is not asked in the problem, but I think this is more interesting. If, instead of just a single number, which this is, I asked you to come up with an interval for the proportion of male that happens to be advertised, how might you go about this?
I would look at what your extremes could be. Your 14.8 over 27 as your low end, your 21.2 over, or your 18.79 over 21.2 as your high end, and
That's good. That's
Yeah.
great. It's quick, it's dirty, and it works. There is another way that's longer, but probably give you a better answer. Give you a clue. We've been talking about it for the last 20 minutes. Excellent. And the confidence interval of what? Okay, 95% confidence interval, that's great. Of what? This goes back to how do you treat your data. You don't have to treat your data as just something that you leave alone. You can mess with your data. You can do stuff with your data. What might you do to get a better estimate for?
Raise the sample size.
That's true, but that would involve getting more data. Even without getting more data, you can do something other than comparing these two intervals. You can massage your data. Now, there are ways to do that that's cheating, but there are also ways to do that that is not. One of the ways that is valid is to look at each individual household and computing
Average
after what?
ads per total mail.
Okay, so for each household, you can calculate that ratio in question, right? The proportion that is in fact advertisements. Then what?
Then you take the data of that and then do the confidence.
Very good. We're not gonna do that unless you really, really want to, but everybody see that? And that would give you a narrower bound, because this way, I like this approach, but,
It is wide.
exactly. And the confidence interval per se is gonna be narrower, and you're able to assign a specific, confidence level to it. Okay, questions? All right, let's take another, 2-minute break, and